Giga castings are the consolidation of what has traditionally been extruded, stamped, cast metal parts into a single front end or rear end body structure part. And Giga castings are all those individual parts are consolidated into a single piece casting. Giga casting is important because it is probably one of the most significant advances in body structure strategy and technology for several generations, probably as significant as when OEMs made the switch from steel body to aluminium structures. It was something that on paper has always had real tangible benefits, but the technology to enable that has never been present, and it has taken the pioneers of the concept of the technology to really drive that into the mainstream, and now it is so prominent it can't be ignored and there's no way to go back from that. Several benefits from Giga casting. So number one, on an economic scale, making one piece rather than having to design, source, manufacture, transport and assemble up to 150 different pieces is a clear benefit. There is a greater flexibility in design as well, so you can design a single piece Giga casting to incorporate many different features that previously would have been difficult to achieve through multi-material assemblies. Giga castings changed automotive production in a lasting way already. It was taking a concept that was previously considered impossible, and in a very short period of time realised it and proven the benefits for mass-produced vehicles. Giga castings are a challenging piece on many levels. Number one, certainly for the automotive industry, they are the largest castings that has ever been produced. Previously, castings were the mainstay of cylinder heads or cylinder blocks or subframes or suspension uprights, or large parts but not big parts. So there is a scale there that has had to be understood and then realised. But also the difference in Giga castings from those traditional castings, i.e. you have very thin walls, you have very long sections, you have different material property requirements, you have different alloy composition requirements in order to facilitate the actual casting, the filling of the part. And then the approach to how those parts can be heat treated, how the parts can be machined, just down to how the parts have to be handled, is not just a different approach, but it's a different mindset to what the industry is used to been working with. You need to pull on your experience and wisdom, but not be defined by it. You need to understand how to make the metal, but not be constrained by the usual rules associated with that. It's not difficult, but it is different. And in order to realise that difference, there has to be changes in the process, there has to be adaptations to the process, there has to be innovations to the process to facilitate how the parts are created. They're big. We need to get our heads around the change in scale. It's not an incremental change in scale of these parts, it's a step change in scale. They are significantly bigger than anything the automotive industry has done before. Traditionally, large castings of these scales have been reserved for industries such as oil and gas or shipbuilding, or potentially some aerospace, or maybe defence, but the focus for those industries has never been on lightweight. They're always attached to very large machines. They've got a lot of power and have been designed to manage that mass. Whereas automotive, it's all about lightweight, because lightweight is efficiency. You know, the more weight you remove from a vehicle, the less energy it needs to power. The less energy you need to power, then the more sustainable it is, the less fuel it will use, the less energy it will consume. So it's taking an existing concept and using that. And the idea of mega castings has been around for a number of years, over 50 years, over 100 years. Just the technology has never been developed to really harness all the benefits in a mass volume production scenario. The body in white used to be a huge complex assembly of many different mixed material parts that all needed to be designed, sourced, manufactured, transported, jigged, assembled to create the final complete part. Giga Castings does that in one. And the benefits, apart from shortening that supply chain, about reducing the complexity, but you've also got improvements in quality. If every part is the same, then you don't have the part-to-part variability that you would do when you're creating a 150 part assembly. The amount of energy and time that goes into that is vastly reduced. And it's the simplification through a complex concept that delivers a true benefit for the end product. I'm not sure it does. I think with the level of commitment required to moving forward with the GigaCast program, you need to be very firm on your architecture. So actually there isn't a lot of room for making small incremental changes. Once the die sets are in place, it's what you've got. It takes a lot of time and a lot of money to take out and make modifications to die sets. So that lack of flexibility is both an opportunity and a risk. It's a risk in that if you get something wrong, it can be very costly and very time consuming to get right. Hence the value in prototyping these parts, because you can see what you're going to get in advance of that before you have to make this multi-million-dollar commitment to the final production tooling. But equally, having that inflexibility can drive a discipline back into the design process, knowing that there is no opportunity to do service fixes or can you just tweaks and modifications, mean that the quality of engineering has to be there in the first place. There is very little opportunity to recover. So it drives that discipline into the process, it drives the discipline into the engineering, it drives the discipline into the strategy to say, this is a commitment we are making to our vehicle line for the next 5 or 10 years. And these become the hard parts of the vehicle. And everything else around that vehicle needs to be designed to work with that, rather than the assumption that everything in the vehicle is up for change. So it sets a hard point, and that's very important in automotive, where design flux is apparent right up to the final launch stages. To have that hard baseline that can't be changed is very valuable. So there are two approaches that the industry is pursuing. Number one, Giga casting, and number two are the mixed material assemblies. Mixed material assemblies deliver higher performance in terms of nodal stiffness, lightweightness, but they come at a cost. There is a significant cost premium to using those structures, which is why they are potentially better suited to not low volume, but lower volume premium segment vehicles. Giga castings, where the stiffness, the lightweightness, the other core attributes are not as important as the cost of manufacture, means that they are better suited to higher volume, more accessible products. That technology will only be developed as alloys capability increases and new material compositions are developed. The opportunity to reduce wall section, to remove mass from the Giga casting will only improve, and then that will make it more appealing for the premium segment vehicles. But at the moment, it basically comes down to what are your target attributes and what is the solution that best fits those. The future is now. The future is here. I think can't say that Giga castings are the future because they already exist. I think they will continue to exist into the future and they will only get bigger. At present, the biggest Giga castings we've got are half a car, front of a car, a middle of a car, back of a car. But when are we going to see all of a car? There are OEMs that have filed patents for machines that are capable of creating a whole car body structure from a single high pressure die casting. And it's only a matter of time until that's realised. And the jury's still out as to the benefits of the business case or whether or not that is going to be sustainable for the manufacturing of automotive products going forward. But in a technology, the boundary has been crossed. It's been proven that it can be done. The big castings can be done. There is a discernible benefit that can be taken from those. So really now the sky's the limit. The main promoter of Giga casting technology has been Tesla. They were the ones that invented it or started with the primary users. We do know that in China there are about 40 domestic brands that are currently using or developing GigaCast solutions for future vehicles. I'm not aware that there are any European or North American OEMs other than Tesla that are currently using it. Giga casting machines are expensive and they take a long time to make. The tools that go in the machine are also expensive and take a long time to make. So if you're an engineer and you're working in a body structures environment within an OEM and you have a design as part of the vehicle architecture strategy and you need to support your pre-production builds and do functional validation at a component level or a system level, is it feasible to spend 10, 20, $30 million on a Giga casting machine to go and prove a concept? I don't think it is. So what we can achieve in sand casting is allow our customers for a fraction of the price and lead time to see into the future, to have as close to production representative parts as we can deliver and take those and do the component level, do the system level, do the vehicle level testing to validate the design, to validate the concept, to validate the product, which then gives the data and the confidence to be able to make the decisions to make these multi-million-dollar commitments to move into the high volume production Giga casting machines or Giga casting dies or whatever may be needed to take it forward.